committee. So sort of maybe raise your hand or just nod if you're a bit shy. Anybody else from BT here?
Excellent.
Oh?
Excellent.
Excellent. That includes mention this as well.
Yeah, there's a few admins to it, I think.
Anybody from suppliers of sort of data-related technologies, Oracle, Teradata, any of those, been one of those? Okay, I won't ask you that. And then who's some sort of large enterprises, so kind of government departments, FTSE 100, about half of you, and small enterprises, independents, those kind of things. So yes, so we've got both ends going. And others perhaps having their best. Okay. And of course, finally, I think we've got actually genuine chief data officers in the audience. So we had a chief data scientist cover that. Okay. Good. All right. Well, that's quite an interesting audience. We should have some good Q&A. I've not got too many slides. You said hopefully. So Glenn asked me, said, could you come talk about CDO Agenda and how data architecture can help? And so I sort of said, oh, well, that should take too long to it. So hands up then, who thinks a lot? Yeah, quite a lot. A bit? Not much? No, right, we're done then. So the architect's answer, of course, is, well, it depends. And I have to assess what your budget is for the project and all that kind of stuff. But it depends on all the sort of stuff like state of business. State of enterprise architecture, you can't really build a piece of data architecture unless the rest of the architecture. So you control your data centers and applications, all that good stuff. And do you have or need a CDO? So in BT we don't have a CDO. And I'm currently in the position of sort of trying to persuade the rest of the business that data is an important asset. And we should probably have a chief data officer. If you look on our directory, my job title is chief data architect, ... not chief data officer, because I get a lot of stuff in my inbox that's really beyond my remit. So stuff like how do we value our data sets, that's really an accounting question to do with something called IAS 38, the bookable value. So what I'm actually going to talk about tonight is, sorry, let me go back, there we go. A little bit of framing sort of stuff about how I view the industry and what's going on in the industry. A little bit of discussion about the chief data officer role, as I see it. There's obviously lots of different opinions. And then I'll move on to talk a bit about BT's architecture, our data architecture and some of the challenges that we have, why they're data related. And then I'll talk about some of the examples of what we're doing in data related technology. So in terms of that framing question, this is a slide not terribly clear, but basically IDC did a paper a couple of years ago where they talked about introducing the concept of a third platform, which happened to coincide nicely with something that I was talking about the same time, which is called peak relational. So saying actually the volume of data we have in our relational databases is approaching some sort of maximum, a bit like peak oil. So just quickly do the build on this. So so the first platform really here was sort of in the 1960s, and we had mainframes, and a lot of us still have mainframes. And we have a really substantial mainframe, and actually we're going to be moving one of those mainframes because it's actually right in the middle of Harlandsworth. So we now have a mainframe migration project underway. One of our big data projects is also a mainframe offload, because the economics of the mainframe are driven by the CPU cycles. So any query you can offload off the mainframe actually costs into the big data business case. And then for the last 20 years we've been doing sort of client-server applications. Latterly service-oriented architecture is dominant. Looking relational paradigm as being the dominant paradigm. But of course nowadays we're into this world of polyglot persistence. It's a useless word, but there you go, it's caught on. And we're talking about big data architectures. So our computing has gone back, instead of being distributed. If you're into big data world, you're actually into cluster computing. And guess what? A big data cluster looks just like a bleeding mainframe. So actually, we're back around circles. So, and people say, oh, are you using any NoSQL databases? I say, yes, we use IDMS. It's a graph database. And they have to look at me blankly because most of them don't understand what IDMS is. Anyway, so we have this third platform. This red and yellow colour scheme will come through some of the slides. But basically, a lot of our existing sort of client-server applications are being connected into these big data lakes or data hubs, and this is the sort of architecture we're seeing here. And the things that we're thinking about now are mobile applications. So within BT, we have a very large field force that are all equipped with iPhones, and now we have an application deployment scenario of 30,000 smartphones. Social media obviously is an engagement channel and something you have to listen to. Big data is something that I'm involved with. And cloud infrastructures, and a lot of enterprises obviously looking at, should we put our applications onto cloud? We're actually an infrastructure company, so we don't tend to move that. We're also a cloud provider as well to some government departments, so it tends not to be an area. So that's kind of when I think about what's going on. I think a lot of the CDA's role is to try and help manage the data across that and manage this move to this third platform. So, and it's not, again, it's not about throwing things away. It never is in our industry. It's about augmenting it and building new capabilities that allow the business to move forward. Just quickly in terms of where we started on the big data piece, so if that's the sort of 10 years that we've had Hadoop around, which is a convenient time frame for measuring big data, we stood up our first cluster in 2009, and we went into production 2 years ago in 2014. So we know a little bit about this technology now. So what do Chief Data Officers do? So if you're interested, I advise you to have a look at Judy Steele's books, and O'Reilly books, a free PDF you can download. And they sort of talk about 3 themes in terms of evangelizing and helping make that change. So that move to this new architecture, modern hybrid architecture, is a change. It threatens a lot of people. It threatens some BI people. It threatens some data center people. So there's actually, there are battles to be fought and lost here. Particularly in the case of self-service data analytics. So we're quite a strong advocate of that within the organisation. We should believe that data should be given back to the business under suitable governance. But that challenges a lot of actually what goes on within our BI and warehousing worlds today. The things that used to be done as a sort of commercial transaction are now actually provided as a centralised service, and that's a change some people aren't comfortable with. Julie talks about it in terms of centralised. I really talk about this in terms of tackling the silo problem, the fact that one of the things that we did when we moved off the mainframes, we suddenly broke the data across the 4 winds and produced all of these little departmental silos, and then that got worse as people started aggregating with operational data stores, and so that's a problem that needs to be tackled. She talks about this nice theme in terms of in the first year of a CDO's job, first thing they should do is build that house that brings that data set back together again. Once you've assembled that data set into this data house, you should then throw open the doors and invite the organisation back in to take access to its data. And the other sort of theme that I spend a lot of my time doing is education. And that comes in a lot of different forms. So we take, with the new technologies of big data, there's endless material you can Google on the web and stuff on YouTube, but actually the value is setting in that context in your own organisation. So we have a cookbook that my team produces, I edit, of design and solution patterns that are not just about this is Hadoop or this is how we use Hive. It actually says, in our organisation, this is how you order the Hadoop service. This is the type of project that we want to put on. This is the security of our Hadoop platform. So if you're assessing it, you can understand it. This is the way we integrate an Oracle database. In our case, we're a big Oracle shop. So this is how we integrate an Oracle database with our Hadoop clusters. This is how we're going to integrate the mainframe with Hadoop and so forth. That cookbook of patterns is something that we edit. And we spend a lot of time using that because it allows us to explain to people how we want them to use the technology and allows them to learn the skills and actually get on and get their jobs done. And then spending a lot of time on briefings and all hands calls. I do a mix. We have a number of architectural themes, academy groups. So we have a programming sort of theme within the organisation. We have an architecture and solution design community. I do quite a lot of talks on those. And use sort of things, the odd hackathon and so forth, where we go along, we use our big data platforms and other NoSQL technologies to educate folks. And then tooling as well, so enabling the business. So after about the first year of introducing our big data platform, we found that people were doing the same thing again and again. They were connecting a database into HDFS, and actually they were having to struggle lots of arcane syntax about how to use various different complicated commands. And so we said actually it would be better if we did a toolkit, and we've actually produced an open source toolkit called School. It's on GitHub, you can go and get it. And it just basically says, okay, you put in your Oracle credentials, the tables you want to move, and then the same stuff on the Hadoop end, and it sets up all of the necessary kind of cron jobs and boozy jobs to make that happen. So this is kind of all about that enablement. And then if you want to think, okay, I'm always looking for good role models and interesting people. This is Julie Borgalo, who is Chief Data Officer for City of San Francisco. If you're interested, I'd advise you to go to data.sf.gov.org. They've done a really great job on their website. It's not terribly visible here, but this is a data catalogue of data sets that have been. So what Joy's done is she's gone around the different departments within the city and got to transportation and housing, and these were departmental silos, and done the same sort of thing that Roger Shadbock has done over here with open data, in terms of making those data assets, bringing them into a central platform, governing them as a catalogue of data, and then providing access to them so that they can make a better job of running the city of San Francisco. And it really is interesting. There's a nice data strategy on there, and that's kind of the sort of role model that I choose when I look at the role of the CDO. So, if that's kind of my opening gambit in terms of what I think what's going on in the industry and how I think it's doing a good job, I better go back and look at what's going on with BT, which is not necessarily quite so. Anyway, very limiting as I'm on video. Anyway, this is where we are structured-wise as of April this year. So most of you will encounter these guys at BT Consumer. That's what provides a lot of you, hopefully, with your broadband, and also some of you might have any mobile phone, because obviously they're now part of the group. The bits you may, or some of you, obviously we have some government people here, will know us through our work with business and public sector, so supplies to UWP. We have a pretty large global organisation, so that's also selling to multinationals, but also we are actually offshoring, so we use a significant amount of offshore resource, so managing data onshore offshore is a huge part of what I do. Wholesale and vendors, which is what supplies everybody else with networks, and then obviously OpenReach. And OpenReach is one of those things like in the finance industry where we have a Chinese wall. Nearly all of their IT infrastructure is sort of separate physical infrastructure with air gaps, so that if any sort of person decided they want to push them off as a separate company, that's now technically quite no work. It's an undertaking we took when we were split out as a PLC. All of those market-facing units get their technology from a single central IT shop, which does all of the tech, all of the IT, and all of the networks. So this is a pretty big operation here. I think there's 11 or 12,000 people in there, run by a nice chap called Howard. Within there is the Chief Architect's office. Within there is the IT shop and enterprise architecture, and that's where I sit there. Also, we have research and innovation function there. About 300 people doing what you would call R&D, based at Astral mostly, which is where I am. And they actually where we drive a lot of the thought leadership and thinking, and they collaborate with external organisations, so we're involved in the computer science and AI lab at MIT, and also we have a couple of people based in Silicon Valley that keep us current in terms of what's thinking in that innovation. So, and that's the kind of revenue split there between the logs. So if I then say, okay, within each one of those business units is a set of technology supplying those customer sets, and they're quite different sets of products. Then each one of them, though, tends to have the same generic set of systems, just built at another point in time. And this is sort of broadly how we represent them. We tend to think of them as the stuff at the front office, the BSS, business support systems, CRM, that kind of stuff, facing out to customers. That could be consumer customers, or it might be a small number of wholesale customers. A lot of glue in the middle by way of service management, so when you finally do get through the call centre and they've logged your case, that will go onto a workflow management system that will manage that. If you're doing ordering service, then there's a lot of workflow involved in that. We have a North Allerton warehouse operation, so a lot of that stuff is all automated. And of course, as I mentioned earlier, the field engineers And then the bit which was, well, I spent about 10 years building network management systems. So these are systems that were big data systems before anybody used the word big data. So it's quite normal for us to have to ingest 100,000 events a second and figure out which of those 100,000 we could throw away so you could actually process the 4 that were interesting to us. So I spent a lot more time doing that early on. And then all of those systems tend to plumb together typically with an ESB and an enterprise service bus. With a set of services, and then they all tend to replicate their data into the data warehouses, and the data warehouses attempt to produce the BI. So within each business unit, hundreds of systems. Typically we have 6 major data warehouses across the business. Client server, I talked about mainframes. Total storage of that lot is about 20 to 25 petabytes. We did a survey about 2 years ago to look at that, which is actually, when you think of it in today's figures, is not that much. And the dominant set of data that we have to manage in terms of volumes of data is time series data. So web clicks from bt.com, people starting BT Sport application, all of the stuff that comes out of the networks and IT infrastructure, huge volumes of telemetry, and of course the precious data about customers and their contracts and the bills and the payments and the usage, all that stuff. And a lot of security data, cyber analytics is a big area for us as well. And within each one of those business units there's a CIO function that actually acts as the spender of IT, and I tend to guide those CIOs in their data strategy and roadmaps for each of the business units. And probably the biggest complexity that we have is, the biggest challenge we have is one of complexity. This is an example UML static diagram from release 17 of the repair systems in global services. Okay, this stack is released 4 times a year. Each of the lines of business has another, there are in total 76 stacks like this we manage that have to be released on a rolling basis. So complexity and end of service life is a huge issue for us. You know, which of those diagrams are data flows, which of those are SOA control calls? We do have a database that tells us that, but that's the sort of, why complexity is a big issue for us. So where's the master data in that stack? So no designers ever show us that stuff. And as I say, it's 70 odd systems stacks like that one. The other big area for us, of course, is data replication pinball. So, we take customer details in the CRM, it goes off to order management. We have a thing called revenue assurance, which will check that you get billed and pay your bill. We have billing, archiving issues, and the way I like to talk about it is data replication pinball. So every time you shift that data, it's another 15, 20, 25k replication costs, another chance for the data to get out of step. So, that's a huge sort of thing. I'm always looking, whenever I get asked to do design reviews and architectures, are they duplicating yet more data? Then the other one, which is a common one for us all nowadays, anybody know who that is? Dido, yeah, okay, so Dido Harding. That is what happens when you have to sit around in front of 13 MPs and explain why it is you've just leaked all your customer data. Now, I'm not in data security, but one of my jobs, and I always think emotionally, is to keep Howard or Gavin, who's our CEO, out of that chair, and that's not a good place to be. And obviously we are working on GDPR. We've had a mature program around that for 2.5 years now, so we actually think we're already compliant. We're actually moving on to GDPR effectively 2.0 and what we want to do to get beyond it. So those are kind of, and there are multiple legislations. There's credit card stuff, PCI, DSS for handling credit card data, and there's something called IFRS 15 if you're involved with accounting standards. So these are all data-related challenges. And then along comes this big data thing. I actually took on the data architecture role about 7 or 8 years ago, before big data was, and it looked like a nice quiet place to get ready for retirement. But there you go, how wrong was I? And suddenly this big data came along, and suddenly things that were like building Stonehenge, suddenly a couple of guys could get in an Amazon cloud, they could spin up a Hadoop cluster, and they could create themselves a 5 terabyte warehouse if they wanted to, in a matter of days at comparatively low cost, and go Yahoo apps to the data warehouse people. But it is a tremendous opportunity, and people have a phrase that often say to me, you don't get out of bed for less than 10 terabytes nowadays, and I sort of go, that it's about scale, and you have to live this sort of duality. A way I think about it is a bit like the laws of physics in terms of Newtonian physics and Einsteinian physics. They're both valid views of the universe, but when you're operating at a petabyte scale, the laws of data replication, the way you structure the schemas are very physically different to what they are when you're dealing with a 200 gigabyte CRM system with a relational database and a complex normalized schema. So, and it's just this duality we find ourselves living in. So that's us and our challenges and kind of the background stuff. I thought it'd be nice to think, okay, well, what, if I was sort of sitting in the office of the CDO, newly appointed, and it wasn't me, I'd say, well done, and it'd say, what are you doing to help me in my new role? And so the first thing I think we would be doing, so well, look, we're trying to sort out the basics. Yeah? So you guys, TOGAF certified, or you're familiar with DARMA, DMBOK. These are both frameworks that we use. We expect all our architects to be certified, certainly at the TOGAF level. And it's not we don't adhere to it slavishly. I've never had an architectural statement of work. I've had a lot of email asking me for an architecture, so whether that's the same, unfortunately, they don't normally pay. But I think it's really important. And a lot of this is about the basics in terms of, have you got a decent list of your systems? Can you produce a list of your databases? That's an interesting one. So, we're actually very lucky. It's one of these things about, it's a sort of double-edged sword. We've been with Oracle for over 12 years now, and our penetration of Oracle databases is probably in excess of 95%. So it's wall-to-wall Oracle except for the stuff that comes from Microsoft, which has got embedded SQL Server. So we actually are pretty good. Nearly all of the estate is run off Oracle Enterprise Grid Manager, and we can produce very detailed reports on understanding what versions of databases we have. Every week we review all the critical certs we get from Oracle. And that's nothing more than being in control of your view of your estate. Our data landscape wasn't as good as it could be, particularly in the PII space. We've done a lot of work on that in the last 2 years as we get ready for GDPR. We now have a very good view. We did a conceptual data model around personal data. So it's interesting, the GDPR legislation talks a lot about personal, and obviously the DPA stuff has its definition of these are personal items. There's no comprehensive, there's just examples. And so we actually did that. We did our definitive model of what we did. I think it came up with about 130 different entities and attributes that relate to that. And so now we've then been to landscape that across these 2,000 systems. And so we now have a risk model where we're managing that. Perhaps might be another talk we can do later on. I can get Mark who talks about that stuff. But that's, I think that's a lot about, you really have to do sort of the basics out. And there's no getting away from that stuff. Otherwise you're really building on sand. So the next thing that I spend a lot of my time doing, thinking about, is developing vision and architecture. The details of this are not particularly important. I might use it to illustrate for you, but it's just an example of the sort of graphic I use when I'm talking to half a dozen other data scientists or data center architects, so people that build data centers, BI architects, architects that work in individual lines of business. And what we're trying to say is here, there's with those 2,000 odd relational service systems in the red there, actually what we're trying to do is connect them all up to a singular data lake, which is quite a big conceptual leap for a lot of people to do. But then you say, well, let's remember this. Remember what we said, there's 20 odd, 25 petabytes of storage in the company. So actually in HDFS terms, that's less than a couple of million quid, so we can take one entire copy. So actually putting all of the company's data in a single physical repository where we can then govern it and control it is not a big project anymore. And we're already a long way down that road, close to 100 systems already connected in there. What would we say? So important architectural constructs like these boxes here represent application boundaries. So in our application inventory, where we identify this is the CRM system, this is the workflow system, they're all numbered and so forth. They all have a business owner, they all know how many servers are part of them. We have contact lists for who's the support organisation. And one of the things that we found is when you introduce something new into the architecture, is that people sort of think, oh, it's something alien and different. And so they tend to draw a box and they say, here's my thing, and here's this new thing, and I'm building an interface to that new thing. And we have to explain to them that there's nothing fancy about a Hadoop cluster. It's just a big old compute and storage platform, okay? So your application has got to extend into that compute and storage fabric, and you are still responsible for the data that comes out of the relational database when it's on HDFS, or petition HDFS so it's secure. But that application, you're still responsible as the owner of that application for the data on HDFS as well as the data in the relational database. Because if it was on the backup tapes, you're still responsible for the backup tapes. It doesn't, just because it's come out of physically out of your database, it's no longer not yours. So in the current architecture, we're still in a world where the insert, update, delete, so the data lifecycle is still managed, but mostly in the relational databases. The difference obviously being time series data. So you remember all that stuff I talked about, logs and stuff coming out of the networks of IT. Of course, that has no concept of mastery. It's just a singular fact. And so you capture it and you land it and you put it. If you put it into a write-only, effectively append-only file store, that's quite a good place for it. So, too much into the detail. Other things that we talk about, so from sort of helping a CDO, are thinking about who's consuming that data and what are those user groups. We've characterised it now in terms of 3 sort of large groups, and we're working towards those with capabilities. So today's warehouse users, which are the SQL analysts, these are people that know what an outer left join is and can form a decent query with a predicate and all that good stuff. And so they actually move pretty well into this world. They've got a bunch of BI tooling. We actually use a lot of Oracle Business Intelligence and so on. The data democracy thing is just the business users. Okay, so if you go to a user and you say to them, what do you know about SQL, or could you create me a table with put that stuff in? And they go, and they look at you blankly, and you go, okay, so you know what a pivot table is, okay? Do you understand how to do a VLOOKUP in Excel? And they go, yeah. Oh, okay, right, okay, so we have a different tool for you, okay? You don't use SQL, we have a tool that looks like Excel, and it's bolted into this big data cluster, and that allows them to access that data under secure regime. So that's saying actually we want to make those data assets more available to business users who are non-IT people. And the analogy I would draw there is, remember there was a time when you used to have to go to IT to get a website, and they would get you a lamp stack. They would put on, somebody could write HTML, and now we have things like SharePoint. You just go to a site and create an office site, and away you go. And it's exactly where we want to be with the data. We want you to be able to go to a catalogue, say I need this data. We want the catalogue to say, oh, people who looked at that data also looked at this data and that data. So you might want to either speak to those people or look at those data sets who have recommendations around the catalogue. A bit like shopping on Amazon. And then, of course, the data scientists, the unicorns. So I'm privileged to work with a number of data scientists. Part of that research function we have a big data practice, about a dozen guys there who do marvellous things like programming in R and run complex regression and k-means and all that good stuff. And when we get stuck, we call a data scientist. They go, help Simon, come and help us. They use a different set of tooling. They can't actually speak to the BI people. The BI people can't really speak to them yet. It's a sort of dialogue that's starting to close. And they don't really understand why they can't use the same tools, but it's because they're trying to do different things to the data. Interesting enough, something we observe is that data scientists tend to work with big files of data and don't work with relational databases because they find schema constraining. And so actually they want to look at raw data. It's very interesting if you start to observe what they do. And we have a tool called DataMere, but there are other data wrangling tools, Trifactor and Transformer and so forth. And these are things you bolt into your big data cluster. So we have, and what we're doing, initially a lot of what we're doing is things like ETL offload. So when we have a data warehouse that's struggling in scale, we take the big heavy sandboxes and the ad hoc users who are killing our database with random complex queries, and we say, no, don't put all that data down on HDFS and go away and play with Hive and stop killing the data warehouse. We have a lot of things. We had a lot of old batch applications, and the first 4 projects that we had on Hadoop were actually end-of-service life projects. They were 12 and 15-year-old applications written in simple SQL, mostly PL SQL, that came to for funding for a re-platform. So they wanted new VMs, they wanted a new database, they wanted a significant chunk of money to upgrade the database, and then we're going to buy a few new tools just for a laugh in the process. So we said, why don't we just take your existing simple SQL code and port it onto Hive HQL, and you can come run on the platform, because guess what? We believe we can make you go significantly faster, and you won't have to buy any VMs at all. And we have now an active program going around looking for old batch applications that are moving them onto this platform. That has the side effect that we actually bring a data set into the platform. And so we actually, the data, the lake that we build actually starts to gain more and more interest. And you get sort of data gravity effect of people going, oh, well, you've got that data, that's interesting. So one of the first data sets we brought in was a thing called customer master file. not the consumer customer, this is the business customer. This is the Dun & Bradstreet data, for those of you familiar with that. And that was one of the first, and it actually had that data across about 12 different systems. So if a company like, I don't know, BHS or Wilson go bankrupt, that never happened. We know immediately, we produce a golden list every day who we're trading with, and that is broadcast out. And actually that's now produced on Hadoop, and it's now produced in 8 hours instead of 24, which means that we can do an intraday run. The business owner of that system hardly knew that we were migrating it onto a big data platform. All they knew was that we saved them some money and we're producing the data a lot faster, and it's a lot quicker now to ingest new data sources. So that's the sort of thing that we used to talk about that as a vision. In terms of just a little bit more on the practicalities, I talked a bit about the data center guys earlier on, and people that were challenged. When we started doing this kind of move to modern data architecture, the data center people were busy establishing private cloud. So they were moving all their old Linux and dedicated Unix servers, Solaris servers, onto a Replication version cloud, and they were moving that platform. We said, we'd like to spin up this big data software, Hadoop stuff. And they said, that's okay, we'll spin it in the cloud. And so there was an interesting discussion we had over a number of months where we said, well, actually, we went to speak to some people in the Valley who wrote software, some people like Doug Cutting and Amber Bradella at Cloudera, and they said actually it runs best on cheap tin. Okay, this is the whole point of this, is resilient, make the resilience in the software layer. And we don't really want to be taking up your very expensive private cloud resources. In fact, you've ever seen that, that scene in Alien where the alien burst out. This is what this Hadoop cluster, if you put this Hadoop cluster in that private cloud, it will tear apart the I/O, just like that. At scale, you won't notice it for months, and then gradually you will notice that the I/O starts to disappear because all this data management. So that was the team. We took the Linux admins. We said, guess what? We're going to make you responsible for the Hadoop stuff. This is about giving them career development, and we ran a series of workshops. We were lucky enough that we did actually. We had unfortunately Channel 4 beats that year, but. And that was what we stood up. We've just recently refreshed that tin. That's the 2 petabyte cluster in Tinsley Park in Leeds that we stood up. I'll talk a little bit about then. So then we want to make it very easy for developers to consume it, and also for the business to consume it in terms of as a capability to do data and analytics on. So we try to develop like an AWS, Amazon Web Service, or GCP type user experience. And so to do that, this is kind of the second part. This is actually what those physical boxes look like. They actually look like 2 Hadoop clusters. Again, remember I talked about a separate one for OpenReach. We had to do all the hard yards with security. So this is kind of another group of people I spend a lot of my time talking to, the InfoSec people, who like to have everything encrypted in every direction and every disk and this possible point. Of course, their world is dominated by something called Active Directory. Anybody's familiar with any corporate IT knows that all identity is managed in AD, and that's the end of it. So you have to integrate with AD. We do that with Kerberos, and so you get into this bizarre world of principles and all that strange language they've created to obfuscate it. But the bottom line is that when we want to create a bunch of artifacts on the platform, so something like our Hive database, or some folders on HDFS, some storage, we actually create a security group and Active Directory, and then those are all bound to the Active Directory group structure. So that's the kind of what the big data platform looks like. We have user access up the top, so I talked a bit about the data mill, which is the Excel-like user interface. Obviously the BI users are going in via things like OBIE, the business intelligence, so that's kind of users. The user admins are obviously all done off Active Directory, so we didn't have to handle that problem. And then we have these kind of projects, and we have now 360 odd projects on the platform. So you as a project owner, you might be part of it, you might be a designer or an architect for a business application. You could be somebody from the business who wants to do some analytics. So we have a whole range of operational people that want to get on and join different sets of data. And so you, if you're coming in as a business person, we run you through some extra governance. Something called the Analytics Review Board, which meets on a weekly basis, and we process 4 or 5 requests a week. And then you then literally get into a service order form. It looks like an AWS form, basically says how much you want, and that's what kind of goes into that process. And at the end of it, it just mails you back and says away you go. And then when we're integrating with systems, we use something called Flume, which is the telemetry ingest, or we use a RESTful exposure of the file system. So when you want to move files, you just use a URL and put those files in there. So the detail of this is not really that important. What is more important is that we start out very early on in things that this is how the architecture is going to be, because we want it to be mostly about facilitating the business or facilitating developers to do application development faster, quicker, cheaper. And most importantly, in the back of my head, which nobody is not, no guy's stroking the cat, no, there's no strategy to do this. It's about bringing the company's data back together from all of those silos. There is no program, you will find no business case that says we will reintegrate all our data. We just find a set of architectural patterns that lead you in that direction. So that's kind of where we go. I would be remiss not to talk about data governance. So I'll talk about, this is the work in progress that we're on at the moment. So I talked a bit about how we'd like to have the data catalogue and what we call the million table metastore, because if you think 2,000 applications, most of those applications have got something like 1,000 tables in, the bigger ones. The small ones have got 200 or 300 tables in. 1,000, so you end up with 1 million tables you've got to manage. That's a search problem. That's all that is. That's a big old search problem. And so we've got some work going on in the data catalogue. The bit in the middle is the bit that we're working on. So this is the thing that says, okay, having been through and selected the data I'm interested in, I now need to get authorization to look at that from a set of data stewards, business data stewards, and this is and a lot of debate about who should own which data set. I'm sure anybody that's involved in that has a similar problem. But once you found the data you've wanted and you've been authorised to use that, then we actually don't want then anybody else to be involved. We want to actually automatically create views of things like orders and customers and faults. So it will go away that, as I talked about, it would potentially recommend to you. One of the things that the research team is working on is schema analysis that says, actually, we're going to analyse all those million tables, and we're going to go look, understand what are the data sets that are joined together. It's very interesting when you start to draw graphs of saying, oh, actually, you know what, there are only actually so many distinct sets of groups. All of this other data, which is spread across those thousands of systems, is actually joinable together because there are columns that are suited to be matching keys. So it's a very interesting one, though. The research guys have sort of moved on from the basic Hadoopy stuff to do much more interesting, more valuable work. And that's it. When I say data governance, most of it we're working jointly with Group Legal on a framework that mandates all of the business units to have in place these business data stewards and the roles that they do. So it's not just this stuff, there's things like, if you're responsible for a data asset, you must produce a quality and an audit report on that. So you need to produce regular data quality reports. In some business units we do all that stuff, and we understand what the level of dupes is and what the missing number of records is. In other areas they don't, and it depends on the nature of the business unit, how good they are at those sort of things. So that's a big area. So that's data governance, and then the other thing that we do is continue to educate. So and this is something that I think data architecture can lead on. That's kind of final slide. So we talked about those guys. We still run operational training courses. I do a number of sort of events like this. We do a lot of stuff with user groups and meetups, not dissimilar to this. That was one we ran for User Group UK a couple of years ago in BT Centre. Every year we run an annual data science week. It's now actually this Christmas will be its 4th week. That's about 50 people in March, and we're on based. That's a member of the data scientists that we have get there from enrollment. So we run that course, and it's not quite residential, but you have to come to the thing for full time for a week. And they put together a structured a syllabus, you install R, they take you through some basic statistical monitoring, and we target particular business transformation people or areas of business where we think we'll get a high return. So it's not like anybody can come along. We actually target the people we educate because it's quite an expensive operation to do that stuff. I've talked a bit about the school utility that we wrote. That actually came out of our Bangalore Centre of Excellence. We have as well as the partners that we work with, we actually have a BT office now in Bangalore with about 800 people, and those guys are now our big data centre of excellence, because we didn't want to be training our subcontract suppliers in how to use big data technologies. We thought it would be a good idea if we kept that in-house, so those guys are doing that stuff. I've talked about the cookbook, the work that we do with MIT as well. That's Matt Zahari is the guy that wrote Apache Spark, and those of you that are into that sort of technology. The architecture I showed at the beginning there is sort of the 1.0 architecture, and these things never stand still. So if that was very much a batch-oriented architecture, remember that diagram about how the mainframe started out with tapes, and they were all very batch-oriented, and then they became, they got 3270s and concentrators, and we suddenly had 8,000 users. Exactly the same thing is happening in the world of big data. Now suddenly all of let's have a big file system with batch processing, is suddenly go, oh no, let's put the data back in memory and run super fast machine learning algorithms on it. And so actually, we're seeing this massive acceleration and another set of technologies we have to keep up with. So our supplier that we work with, the Choice of Scadia in that space, but there's Hortonworks and Metal and lots of other good technology in that space. And that, I think, is a whistle-stop tour through our data architecture.
Great, thank you, Phil. I think for me that's certainly triggered a heck of a lot of questions I'd like to ask, but rather than me being up at the front monopolising, let's throw them to you guys. The guy there very quickly got his hand up.
You started off talking about one of the roles of the CDO in terms of culture change and turning the business into a kind of data-driven business, but you didn't really say very much about that.
That's because I've ultimately failed at that. So I'll answer that first part first. So Gavin, who's our CEO, Patterson, John Patter runs consumer, and even Howard, who runs our IT shop, are all obsessed with stuff other than data. They're obsessed with the 12 billion quid they spent on EE, the £1 billion they spent on TV rights for Premiership football, and making sure all of that serves. I spend my time waving a flag going, data. Don't you want to be like Google? Don't like Facebook? No. But of course, when you've just spent £12 billion and you have to show a return on that asset, that's what's set around for you. But they do get it, and they're supportive of us at the level of in terms of saying, when we say things like we want one data lake, we do not want a data lake per business unit, then they help us make those important things happen.
But you seem to be concentrating on the supply of data to
Absolutely.
the business.
Yeah.
The business is making decisions based on your data. So
Their data.
So the matching.
And if it's bad data, they made it bad, and we will produce a data quality report and say, look, 5% duplicate records.
But it's also the question of matching, is this the appropriate set of data to support this set of business decisions?
Yeah.
So how much do you get involved in the decision making that your data is supporting?
So you're getting into areas of sort of strategy, corporate strategy development, and that kind of business transformation. And we have armies of people with MBAs that do that stuff as kind of day jobs. So
as part of the CDO organisation, or are they?
Normally they're within. What we tend to find is and say something like John Peshley, you'll find there's a consumer transformation, and they're concerned with things like what are the major things that are wrong with our business, and our customer experience is in the toilet, or whatever it is, or our network operating costs are too high, or in Openreach's case, what they can do with their field engineers. So they spend their whole time thinking about, would it be better if we sent the engineer the job first and then move them around? So and there are people that do that to make the business move forward and evolve. What they've done previously is they work on this kind of HIPAA, highest paid opinion, the person's opinion wins. And what we're trying to say is no, bring the data. What is it that we say? In God we trust, in all others must bring proof in the data. And so you must show us a data set. And there's a data lineage. You might just randomly produce data sets. You must say, I got it from here and this is the table and that kind of stuff. There's a big tension there though between the BI people and the BI people who say, well, I do RFT, I do right first time for business, so I produce the stats on how many orders a week we produce. And so that's fine, and that will still be the case. But there are other people wanting to ask different business questions that have legitimate right to access that data. And quite often it's one-time business questions which are hard to do in a warehouse, where you just want to, we did a piece of work last year, it's actually a JFDI that came down from Ofcom about nuisance calling, and we wanted to produce a predictive model that said, if you look at an individual phone call, and you look at the dial digits on that phone call, can you predict the probability that that's a nuisance phone call? and decide whether you want to route that call to a network-based answering service. And to do that, we had to produce, we had to land billions of CDRs and a lot of other supporting data sets to allow the data science team to produce that machine learning one. And then frankly, the data scientists were the best people equipped to decide what is the appropriate data set in that data set to use.
Just down here, yeah.
Yeah, thinking from the perspective of, you show us this diagram of from mainframes to finally with the cloud there. So my question is, what are the main challenges that the data architecture faces in terms of moving or updating or upgrading that model? Thinking from the perspective of today's on-prem, tomorrow's cloud, now it's cloud, that transition. So what are the main challenges that this
So I guess it's generic business change in terms of understanding, okay, so what are the changes that are required, who's impacted by those? So in our case, I started with the data center people in terms of working with those people. It's interesting because, and we didn't do what a lot of people, most other people bring big data in through BI and analytics. But of course then you say, well, what about when I want to start running my fraud management solution? Is that now a BI and analytics function? That kind of make a mess of your enterprise architecture. And so we said, actually, no, we keep the separation between application and infrastructure, and we let data storage and data processing be done by the data center team, because that's not. And if they choose to then adopt a hybrid cloud model where they burst out into the cloud for exceptional load conditions, that's their business, because they do infrastructure. But the application piece is still remain the same. The boundaries there are still the same. And there's a tremendous tendency. It's all analytics. We just throw it all over there. And that's something that we say, well, no, we have an enterprise architecture. We understand what applications we are. So that's kind of trying to understand which are the important lines to draw in terms of maintaining integrity of the architecture. Interestingly, so then of course vendors. So the whole vendor story is a kind of, anybody that's listened to one of those 3V bloody presentations or some of those hockey stick graphs, don't like that. So there's no vendors, hardly any vendors anymore. So we gave our own V to the 3Vs, and so we didn't buy a big data appliance from our preferred vendor. We went off and bought a bunch of cheap tin and did it the way, because we spoke to the innovators and they said, well, do it on bare metal. That's the way we built it. But we didn't build it for what you're doing with it, but that was the way it was constructed originally. So there's that kind of stuff. And I think you saw a lot of vendors early on who were producing these kind of, oh, well, you can just buy a different box and pop it in the data center. And that's about them defending the position. So they're challenged. And it's changed the dynamic. I don't get Christmas cards from a lot of our vendors anymore. I don't get invited to those golf trips. But I do get to go to O'Reilly conferences and talk about new and interesting innovation in the world of data. So that's kind of the flip side of it. The other stuff is, of course, if you're radically driving down the cost, interestingly enough, it's hard to get management airtime. The only people that listen to you are the finance people. And the finance people are, but of course they don't really listen until the people in the business unit have said, oh, well, actually, there's this transformation project here. So our investment in those big data platforms is peanuts. Low hundreds of thousands. And when we're talking about a company where shall we roll out fibre to the cap that costs 4 billion? Shall we spend $1 billion on football rights? So actually getting management airtime, when you're saying actually our entire strategy is less than 10 million quid, but we've got to transform the entire company. So most of the time they say, okay, on you go and show us. And then every now and again we come up with a project and go, ta-da, £22.8 million benefit. Thank you. And then roll on and try and find the next one.
Good, okay. Stuart, sorry.
You talked from a government's perspective about who has access to data and data quality. In terms of the activities of the data science capability, is there any governance around ethics of how the data is used, particularly the customer data?
Very good question. So I talked about the data science team, and remember the timeline there, 2009, when they still had their first clusters. So what happened was that they started sucking some corporate data into their private sort of environment. They realised that they were going down the wrong road, and that's kind of why we built the production platform, because we actually want to bring all that back into corporate governance. So, and they still do some data analysis, and they still run their own infrastructure, but mostly they're looking at these things about metadata analysis, and they're looking at is, I don't know, is 10s faster than Impala or some nonsense like that. And so they kind of look at that sort of question. They're not actually looking at the business questions much nowadays. What we do nowadays is, because now they know that the data that they want is on the secure production platform, they know it's basically how it's built, and we copied what they did in research. Then they're actually what we normally do is embed one of those data science people in a business team that's looking at transformation projects, and they can do enough of it. So the nuisance call one was an absolute classic case in point where, and it's funny when you give a data scientist a new data set, they're like Christmas came all at once. and I literally would get these IMs saying, look at this, look what we're seeing, look at these traffic patterns, and these guys are having great fun. But, as you say, the ethics is an issue there. I don't actually think it's the data science guys, I think it's much more a business question. In the data governance piece of work we're doing, we're sort of doing a new framework around that. We have said that so the people who manage bribery and corruption, so we have a kind of fair trade thing, those people will be involved in the data governance. And so there will actually be effectively part of the workflow that will assess, in the way we do is this a privacy, are you dealing with a PII type data set, or are there ethical questions? Now of course, if you're doing something unethical, you may say, oh, but at least we've got to build those in, and we think we need to acknowledge that stuff. But I think you have to be we have to go a lot more in terms of our maturing from where we are today to get somewhere closer to Facebook and Google before we start getting to those issues. I think those guys are the guys that have got real issues.
John, I think you've got a question.
It wasn't really a question, it was more to emphasise the point about the actual physics of the analytics that you're looking at, because your IBM mainframe is great at data throughput, but actually if you've got a computational problem, you need to actually think about the computational side of it and how quickly you're going to get the response. And your point about bare metal, you also have to think about bare metal where you want high performance
compute or
or high performance capability.
Yeah.
And that can be the difference between spending 5 million and 500,000.
Absolutely.
So when you're looking at the business problem and the data science that's being done, you need to really challenge about, do you really need it that quickly? Do you really need it at that business time frame, especially if it's offline analytics?
Yeah. So interesting. So that original stack was the first stuff we put in 2013-14 was optimised in the world of map use. And so we actually designed it from ground up. We looked at the CPUs we went in, we said, okay, we want a one-to-one spin to core ratio, so each core is something about stream off a disk, and then writing it back to that disk. And then along came all of these kind of new in-memory technologies, and we went, oh crap, we've got memory. And so actually that's what the refresh we've just done is, to significantly, we actually reduced the number of nodes, but we've actually significantly increased the core count and the memory footprint by vast amount of memories. I still think, why have I got 2 GB of memory in my phone, but still. The number of noughts is incredible. So, and indeed, so the data sets that we have today, a lot of that is still relational or time series. We're not big into, we've got some imagery stuff that we're starting to work with. We did a very interesting piece of work with TensorFlow where we were trying to look at, so we have 80,000 of those green cabinets by the side of the road, and we would like to give you all fibre to the home, but that requires us to deploy some more electronics and optics into the network. The question is, how many of those cabinets have got room to put those optics in? And actually going around and manually assessing them is quite hard. And so we did an interesting piece of work where we took 80,000 JPEGs of cabinets with their doors open just as part of it, ran them through TensorFlow, and so TensorFlow sort these into empty, full, mostly empty, mostly full, and they did it in on the general purpose of it did it in about 6 hours. We did some GPU boxes which we bought in from a vendor, and that went down to 6 minutes. So it's exactly your point, is that the right hardware computation problem is important. So.
Let's go to the question.
I thought it's a great pragmatic approach on the deployment of the big data platform. You're obviously leading with, it's quite easy to migrate old systems with like PLSQL, for example. And it was one of my questions to ask you how you got on with your Oracle account. But
they keep telling me the VP's coming over, you want to talk to them.
But be pragmatic, you've also done the same thing with TOGAF. You
Yeah,
You have to
absolutely.
be selective with it, otherwise you'll just get seen.
Yeah, I mean, if there ever was death by PowerPoint, it was a
Yeah.
terminal.
So I'm particularly interested in, you mentioned that you're virtually GDPR compliant.
Yeah.
That would say to me that you probably need a master data management solution. How
Well,
to approach that?
Okay, so master management. So for GDPR, you just need to know where the data is. Okay, you do need to have some degree of control of it, and we await the ICO audit with some interest, because obviously the thing about GDPR is they can come and audit you if you want, whereas previously you had a breach. But we have now a pretty good landscape on what's in where. We've done an extensive schema trawl across those 2,000 situations. We have on the key data sets, so consumer customer quite lucky because it's actually mastered within the CRM system, and so we have a pretty good handle on that stuff. Address data, we just, okay, audit survey, that's fine. Commercial data, Dun & Bradstreet, you're the external reference master, so we have pretty good strategies in all these areas. The one, I guess, is the one that's our own problem, which is the network topology, which is always a challenge, particularly now as it gets more and more dynamic, so it comes and goes sort of, on a second by second basis. We use a lot of discovery techniques, so we regularly sweep the network configuration. We say, okay, tell us, Mr. Node, Mr. Router, Mr. Switch, how many ports are active, what ports are connected to where. We then run discrepancies between what's in the network and what we think is in the network in terms of inventory. And we have some loops where they'll go out to manual data quality issues. So it's the sort of things where in repairing a custom fault, you might say, well, we'll just stick them back in a 10 gig instead of a 1 gig or something like that. And that discrepancy will pick up. Typically, it's part of a billing cycle where we'll say, actually, we're getting 10 gig, but you're only paying for 1 gig, so something's got to change it.
Good. I think time for one quick question, so lady in front here, so.
I'm a data scientist for a long time. How flexible are you to allow the data scientists to play around with open source things? Like I use MongoDB like crazy, and I'm all over GitHub getting things that have been already built so that we can start analyzing our hypotheses.
Yeah.
How crazy would you get at me if you discover
we'd probably annoy you intensely. So we don't allow. So that the big data platform is intensely configuration control. We have a roadmap that says what the features are. It's full change control when we upgrade it. You know, there are cases and calls and God knows things like change control. So and when we get support calls, we had a support call, great support call, that said. I can't connect to the HBase meta store. Can you tell us what the URL is? And we said, that's because there isn't one, because we haven't turned it on, and we're not going to turn it on, because we've got this. But the other thing in our company called Oracle, and if you want to serve a database, please serve the Oracle database. Well, that's part of my other remit in terms of it's not all about big data, and there are other different types of data. So graph databases is another thing. It's got nothing to do with Hadoop at the moment. Well, it might do with Spark. So we use quite a lot of graph. We use some document databases where the business problem is document origin. So I think you need to sort of separate the difference between, and we get people that are trying new data technologies versus actually doing genuine data science and actually doing a statistical analysis of data, and that's got two slightly different things. But we'd endeavour to, we'll probably put you into research, because those guys still have their own infrastructure, and if you genuinely need it, they can do that stuff.
Good.
All right.
Okay, right. I think we'll draw the questions to a close there. We'll have just a break anyway for a bit of networking, so we can carry on the conversation then. But just like to join me in thanking Phil. We've got a small gift from the BCS.